In this example, we're going to graph the quadratic function y is equal to 2x squared minus 5x plus 3. The first step in this is to complete the square on the x squared and the 5x by factoring the 2 out. So we have a coefficient of 2 times x squared minus, if we do 5 divided by 2, we can just say 5 halves, leaving the 3 out. We're going to complete the square on the same side of the equation, so whatever we add, we have to subtract. We're going to add an unknown inside x squared minus 5 halves x. Represent that with a box, plus 3, then minus the box that we added. However, that wasn't really a box, that was 2 box. So to account for that, we also have to multiply whatever we subtract by 2 as well. Furthermore, what goes inside that box has to be half of the middle term, 5 halves squared. 1 half times 5 halves is 5 fourths, then 5 fourths squared is 25 sixteenths. So we end up with 25 sixteenths going in both places. So we get y is equal to 2 times, we're going to factor minus 5 fourths squared plus, this would be 3 minus 2 times 25 sixteenths is 25 eighths. So now we end up with y is equal to 2 times x minus 5 fourths squared. This would be 24 eighths minus 25 eighths. Now that we have it in graphing form, we can identify the important characteristics of this. First of all, we know it's an up-down parabola because of the positive 2 coefficient. We know that it has a vertex at the and negative 1/8. So we can graph this. I'm going to choose to scale it so that every box is 1/4. So 5 fourths negative 1/8 would be right 5 and then down 1/2 here. And we said that this is an up parabola. So I know immediately it's going to be going something like this, and it should have 2 x-intercepts and 1 y-intercept. It's also going to have an axis of symmetry, a vertical line going through x is equal to 5 fourths. We should find our x-intercept and our y-intercept. Let's start with our x-intercept. For an x-intercept, for x, you can do this by going into the completed square part of the formula, or by using the quadratic formula in the original. So 1 is equal to x minus 5 fourths squared, or plus or minus 5 fourths. And that means that x is equal to 5 fourths plus or minus 1/4. And our two possibilities are 5 plus 1/4 over 4, or 3 halves, and 5 minus 1/4 over 4, or 4 fourths, or 1. So 1 1/2 or 1. Well, since every box is 1/4, 1 would be right here, and 1 1/2 would be right here. And this looks good because they're both symmetrical about the axis of symmetry. The y-intercept is a lot easier. All we have to do is let x equal 0. So I'm going to plug 0 in for x, and if I do that in the original equation, way back up here, I see that y is going to be 3. So I know that, again, 2 times 0 squared minus 5 times 0 plus 3 is equal to 3. My y-intercept is 3. Because of the enormity of my scale, my y-intercept would actually be 12 boxes up, or here, and then on the same point, reflected about the axis of symmetry, so 5 more boxes over, and right here. A good idea would be to do a t-chart and get more values between these points and these points, but we're just going to connect it and be done for now. If I can get this right.